Hello, my students, and welcome to the first episode in my series on complex numbers for secondary one. And in this episode, we are going to talk about the complex numbers. What is the meaning of the complex number? How can we simplify them? How can we add? How can we subtract? How can we multiply them? So, if I have something like square root of negative 25. And what is the meaning of the square root of negative 25? This means you must find two numbers. When multiplying them, we get negative 25. And there are not two exact numbers. When multiply them, we get negative 25. And if you did it on the calculator gives you a math error. Why is that? Because there are not two exact numbers. When multiplying them, we get negative 25. But we can write the negative 25 as 25 multiplied by minus 1. And when having two numbers under the square root like 25 and minus 1, we can write square root of 25 times the square root of negative 1. Suppose that the square root of negative 1 equals I. Because I don't know what is the value of the square root of negative 1. So I suppose the value for square root of negative 1, which is I. And I stands for imaginary number. I don't know the value of the square root of minus 1. So we write it as 5, square root of 25 is 5, and the square root of negative 1, it's I. So it's a 5I. What if I ask you about the square root of negative 16? Okay, square root of negative 16, there are not two numbers which are the same. When multiplying them, we get negative 16. But we can write negative 16 as 16 times negative 1. And we can write square root of 16 alone times the square root of negative 1. Because if I have two numbers under the square root, we can write each number under the square root. So I have square root of 16 multiplied by square root of negative 1. Both of them under the square root. So we can write it as square root of 16 times the square root of negative 1, as you see. And the square root of 16 equals 4. And as I told you that the square root of negative 1, I'm assuming that this number is not a real number, and we can write it as I. What is I? I stands for imaginary number. So it's 4I. Square root of 16 is 4, and the square root of negative 1 is I. If I ask you about the square root of, let's say, 28. You know square root of 28, if you wrote it on the calculator, you will find that it's a 2 root 7. Why? Because we can write 28 as 4 times 7. You know, the square root of 4 is 2, so it's a 2 square root of 7. That's it. What if I have the square root of negative 28? It's a math error if you did it on the calculator. If you wrote it on the calculator, you will find that it's a math error because, again, there is no two numbers which are the same. When multiplying them together, we get negative 28. But in this case, to simplify it and write it as a complex number, so we can write it as 28 times negative 1. And the square root of 28, it's a 2 root 7. So it's a 2 root 7 times the square root of negative 1. And instead of writing the square root of negative 1, we can write I directly. So it's a 2 root 7I. And we can use this information in solving a quadratic equation. So if I have x squared minus 2x plus 5 equals 0. Firstly, we will try in factorizing. We couldn't get two numbers. Multiplying them together equals 5 and adding them equals negative 2. So we will use the general formula, which is x equals negative b, positive or negative square root of b squared minus 4ac over 2a. And be sure that the equation, the quadratic equation, is written in the form ax squared plus bx plus c equals 0. Then x equals negative b, it's negative negative 2. Okay, positive or negative, the square root of b squared, it's negative 2 raised to the power of 2 minus 4 times ac, which is 1, c is 5. All of them, okay, are dividing by 2 times a, which is 1. So that leads to get 2 positive or negative square root of negative 2 squared is 4 minus 2 times 1 times 5, which is 20 over 2. So we have 2 positive or negative square root of negative 16. Because 4 minus 20 is negative 16 divided by 2. Now we have square root of negative 16. This is the problem. And the square root of negative 16, we can write it as 2 positive or negative. Square root of negative 16, we can write it as 16 times the square root of negative 1 over 2. And you know that the square root of negative 1 is I. So we will write it as 2 positive or negative 4i divided by 2. So we will divide 2 divided by 2 equals 1, positive or negative, and 4 divided by 2 is 2i. So we have two solutions. And the two solutions are written in the form of the complex number, which is I plus 2, 1 plus 2i, and 1 minus 2i. So the complex number as 1 plus 2i. The first part is the real part. This is the real part. And the second part is the imaginary part. So the complex number is written in the form a plus bi, a plus bi. That's it. So I want to say that the complex number is written as two parts. The first one is the real part, and the second part is the imaginary part. Okay. And because I equals the square root of negative 1, and you know, when squaring any number, any square number, like when I say the square root of 5 raised to the power of 2, you will get 5. The square root of x raised to the power of 2 equals x. The square root of I don't know what is I. Just we will apply the same rule. So square root of I raised to the power of 2 is I. The square root of any number raised to the power of 2 will write the same number. Okay. So as I suppose that I is the square root of negative 1. What if I squared both sides? I raised to the power of 2 and square root of negative 1 raised to the power of 2. So I squared, and as I explained, the square root of negative 1, because this square root is raised to the power of 2, So we'll write -1. So as you know that the square root of -1 is I, okay? And I squared equals -1. What about I raised to the power of 3? You know, I raised to the power of 3, we can write it as I squared. I raised to the power of 2 times I. Because when multiplying like bases, they are like bases, I and I. We add powers. So I have raised to the power of 2 and I raised to the power of 1. So I raised to the power of 2, it's -1 multiplied by I. So I raised to the power of 3 equals -I. So I raised to the power of 3 equals -I. What about I raised to the power of 4? You know, I raised to the power of 4 is I raised to the power of 2 times I raised to the power of 2. And I raised to the power of 2 is -1 multiplied by -1, which is 1. So I raised to the power of 4 equals 1. Having something like I raised to the power of 5. You know, we can split this power and write it as I raised to the power of 4 times I. And why I did choose 4 times 1, 4 plus 1? Why did I did choose 4? Because I raised to the power of 4 is the 1, and 1 is the multiplicative identity, has no effect in multiplying. So I raised to the power of 5 is I. It's 1 times I, which is I. And I raised to the power of 6, it's I to the power of 4 times I to the power of 2. So I raised to the power of 6 is 1 times I raised to the power of 2, which is -1. So 1 times -1 equals -1. And I raised to the power of 7, we can write it and split the 7 into 4 and 3. And you know that I raised to the power of 4 is 1. We don't need to write 1 because it's 1. 1 times any number, the same number. So I raised to the power of 3, it's -I. So I raised to the power of 7, it's -I. What about I raised to the power of 8? It's I to the power of 4 times I to the power of 4, which is 1 times 1 equals 1. So all the solutions we have got I, -1, -I, and 1. I, -1, -I, and 1 in order. So if I ask you about I to the power of 8, again, this one is I to the power of 8. Okay, I to the power of 8 is 1. What about I to the power of 9? We can write I to the power of 9 as I to the power of 8 multiplied by I, and I to the power of 8 is 1 times I, which is I. Okay. And what about I to the power of 10? We will follow the same steps. We will write it as I to the power of 8 multiplied by I to the power of 2. So I to the power of 8 is 1 times I to the power of 2, it's -1. So equals -1. I to the power of 11 equals I to the power of 8 times I to the power of 3. I to the power of 8 is 1. There is no need in writing 1, has no effect. So I to the power of 3, it's -I. And I to the power of 12 is I to the power of 8 times I to the power of 4. And both of them equals 1. So the product of 1 and 1 equals 1. What do you observe? All the time, we have got answers. I, after I, -1, -I, and 1. Just I want to focus on I to the power of 4 is 1, and I to the power of 8 is 1, and I to the power of 12 is 1, and I to the power of multiple of 4, we will end up with 1. That's it. So when I say I to the power of 20, without thinking, it's 20 is a multiple of 4. So equals 1 directly, because 20 is divisible by 4. So we write 1. And I to the power of, let's say, 24. It's 1. And I raised to the power of 4n, equals 1. And n is an integer number. So 4 times n, or any multiple of 4, I raised to any multiple of 4 equals 1. What if I ask you about I to the power of, let's say, 17? So ask yourself about the multiple of 4. So is 17 a multiple of 4? No, it's not a multiple of 4. So what is the multiple of 4 less than 17? It's 16. So write it as I to the power of 16 times I to the power of 1. And I raised to the power of 16 is 1. 1 times I equals I. What about I raised to the power of, let's say, 31? Is 31 a multiple of 4? No, 31 is not a multiple of 4. So what is the multiple of 4 less than 31? Directly, before it's 28. So we can split 31, this power, into 28, and I raised to the power of 3. So I raised to the power of 28 is 1, and I raised to the power of 3 is negative I, as you know. So 1 times negative I equals negative I. That's it. If I want to find I to the power of negative, let's say, negative 3. Before you tackle it, you should know well that if I have a number like 5, it's the same as 5 times 1. If I have a number like 5, so this number is the same as 5 times I to the power of any power of 4. Why? Why is that? Because I raised to any power of 4 is 1. So what I want to say, that to cancel this negative power, and this question is I raised to the power of negative 3, we can just write it as I to the power of negative 3 times I to the power of 4. And why is that? Why I used this strategy? I raised to the power of 4 is 1. So I didn't change the question, just I multiplied it by I raised to the power of 4, which is 1. And when multiplying like bases, we add powers. So we write I, and then we are going to add negative 3 plus 4, which is 1. So it's I to the power of 1. So what I did again, I multiplied the I with the negative power with 1. I multiplied it by 1. Okay? So if I have I to the power of negative, let's say, negative 9, how can we deal with it? Just write it again. It's I to the power of negative 9 and multiply it by 1. Because as you know, 5 is the same as 5 times 1. So we are going to multiply it by 1. But in this case, we will write instead of 1 I multiplied by I raised to the power of, I raised to the power of multiple of 4. Multiple of 4 more than 9. So what is the multiple of 4 which is more than 9 directly? So I to the power of negative 9 times right I to the power of 12. Some students get confused and say, you changed the question. No, I didn't do that. Just I to the power of 12 is 1. Is 1. So when multiplying by 1, we will not do any change on the question. So it's I and negative 9 plus 12, we will add powers, so it's a 3, and I to the power of 3 is negative I. That's it. If I want to simplify square root of negative, let's say 3 times the square root of, let's say, negative 12. So we can write square root of negative 3 as square root of 3 times the square root of negative 1 and multiply by square root of 12 times the square root of negative 1. You know, the square root of 3 times negative 1, it's root 3 times the square root of negative 1, so it's square root of 3i multiplied by square root of 12i. Now multiply 3 by 12, so it's square root of 36. Multiply I by I, which is I squared. So square root of 36, it's a 6, and I squared is negative 1. So 6 times negative 1 equals negative 6. If I have something like 1 over I to the power of, let's say, 10. You know, instead of this 1, we can write I, but I raised to the power of 4, power of 4. So what is the power of 4 more than 10? The power, the multiple of 4, sorry, I raised to the power will be written as a multiple of 4, okay? What is the multiple of 4? This power, what is the multiple of 4 more than 10? It's I to the power of 12 divided by I to the power of 10. You know, when dividing like bases, we will subtract power. So it's I at 12 minus 10 is 2. I raised to the power of 2 is negative 1. If I want to simplify 4 over 1 plus I, you know, when multiplying 1 plus I times its conjugate, which is 1 minus I. So you multiply 1 by 1, which is 1. And multiply the second by the second, it's negative I squared. Okay, so it's 1 minus, and I squared is negative 1. So 1 minus 1 minus minus 1 will be positive, so it's 2. So to simplify it, multiply the numerator and the denominator by 1 minus I up and down, 1 minus I up and down. Okay, because I want to get rid of I from the denominator. So write 4 multiplied by 1 minus I up over 1 times 1, which is 1 minus I times I, it's I squared. So 1 minus I squared, which is 2. So it's 4 multiplied by 1 minus I over 2. Why 2? Because I squared is negative 1. So negative after negative, positive. So it's 2 divided by 2, 1, and divided by 2, 2. So it's 2 multiplied by 1 minus I, which is 2 minus 2I. That's it. If I have something like 5 divided by I, and I want to simplify it, the meaning of simplifying a complex numbers, write it as in the form A plus B I, the real part and the imaginary part. So in this case, we'll multiply up and down by, let's multiply them. We can multiply by I up and down or we can multiply it by negative I up and down. And why negative I? Because I multiplied by negative I, it's a negative I squared. So it's a negative, and I squared is negative 1. Negative times negative positive, so it's 1. So 5 times negative I, it's a negative 5I. And I times negative I is negative I squared. Okay? So it's a negative 5I over I squared is negative 1. So negative multiplied by negative 1 is 1. We will end up with negative 5i. What if x equals, let's say 2 minus 3i, and you write up, let's say 6. And I want to simplify x. To simplify this x, multiply it by the conjugate. So the conjugate of 2 minus 3i is 2 plus 3i. And down 2 plus 3i. So it will be 6 multiplied by 2 plus 3i, up and down. We'll multiply the first by the first, it's 4, and multiply the second by the second. It will be negative 9i squared. And what about the extremes and the means? When multiplying the extremes and the means, it will be 6i and minus 6i. So they are going to be cancelled. So write it as 6 multiplied by 2 plus 3i over, you know, that I squared is negative 1. So it's 4 minus 9 multiplied by negative 1. So it will be 6 multiplied by 2 plus 3i up over 4 plus 9, because negative 9 times negative 1, 9, so it's 13. 4 plus 9 is 13. So we have 6 times 2 is 12, and 6 times 3i, 18i. All of them are dividing by 13. So write it as 12 over 13, the real part, plus 18 over 13i, the imaginary part. This is the simplest form of them. If I have something like 1 minus I squared, how can we simplify it? The first square is 1, the second square is I squared, and the first times second times 2, it's a negative 2i. Again, the first square and the second square, and in the middle we have first multiplied by second multiplied by 2. So you know that I squared is negative 1. So 1 and negative 1 are going to be cancelled, so it's negative 2i. What if I want to find 1 minus I raised to the power of 10? We couldn't multiply 1 minus I by itself 10 times. It's a hard mission. So we can write it as 1 minus I, 1 minus I to the power of 2, all raised to the power of 5. Just I wrote this power as 2 times 5. I split it into 2 and 5. Then we will simplify this expression. The first square is 1, and the second square is I squared. And the first by the second by 2, it's negative 2i to the power of 5. You know that I raised to the power of 2 is negative 1. So 1 and negative 1 are going to be cancelled. So it's negative 2i raised to the power of 5. You know, negative 2 raised to the power of 5, it's a negative 2 multiplied by itself 5 times. So it's a negative 32. And I raised to the power of 5. So I raised to the power of 5, you can write it as I raised to the power of 4 times I. So it's a negative 32. And I to the power of 4 is 1 times 1 times I. So it's negative 32i. Uh, I hope you enjoyed this session. See you in the coming episodes. Goodbye.